Hello and welcome to our presentation. Today we want to talk about the topic IIoT Infrastructures from Sensor to Cloud. My name is Dustin Küpper and I'm working in the product management for position and proximity switches at Turck.
Yeah, hello and welcome also from my side. My name is Christian Knob and I'm working at Turck as product manager for our Turck Cloud.
So what does the world of automation look like today and how is it different to the past? In the past, classic automation was very hierarchical. Sensors provide important information for almost all areas of industrial automation. This can be positions, temperatures, vibrations, pressures, flow rates, etc. Those information are collected by I/O components and then routed to the PLC where they are processed. In the present, many customers have a hybrid system. Beside the process data, IO-Link sensors also deliver additional data. Intelligent field bus modules can skip the conventional directions of data flow and can communicate directly with an ERP system. You may ask, why should a field bus module do that? A good example can be that a defective sensor can be ordered automatically by directly communicating to the ERP system. Christian, how does this topic affect customer processes and where do they improve?
Yeah, I think this new concept is quite important to be in the position to react fast and easy on the new upcoming requirements. So with this new concepts and strategies like you explained with ordering the sensor part, we need to decide which data is necessary to be transmitted to the main PLC for the application itself and which data needs to be transmitted through the edge controller to be pre-processed and forwarded to ERP systems, cloud systems and so on. So it is a necessary thing to think in this new technologies and methods and with that you are very fast and flexible to set up such scenarios. So Dustin, what do you think, what else is necessary for something like that?
Pre-processing. By pre-processing, data can be enhanced and unnecessary data communication can be reduced. Imagine a dual sensor for rotary actuators. These sensors are typically used for end position control of valves, and normally they would inform the user if the valve is opened or closed. That's it. But with clever pre-processing in the I/O, the customer can get an alarm if the time between opening and closing is getting a little bit too long. 500 milliseconds, everything is fine. But 1 second, your valve may be worn out. Better think about a replacement. We will also show you the same example later on here. But pre-processing can also happen directly in the IO-Link sensor. Many IO-Link sensors have integrated temperature indicators, which can indicate an under or an over temperature in your application. Yes, you could always transfer the actual temperature value with every cycle to the PLC and do the same processing there, but is that information really necessary in the PLC? When pre-processed in the sensor, alarms can be transferred automatically with thresholds, and the actual temperature value can then be transferred on demand, again to reduce data traffic. But the benefit of pre-processing is not always to reduce data traffic. Do you know the problem when you want to see the pressure of your sensor and the value isn't 3.7 bar, but it is like 2687? Cryptic data from sensors can be decoded into human-readable values, either in the I/O or directly in the sensor with IO-Link smart sensor profiles. And that data can then be used in the cloud, for example, for condition monitoring. So, Christian, now we have pre-processed data.
Yes.
But what are the benefits of pre-processing data decentralized and of sensor data in the cloud?
Yeah, so I think decentralized sensor data is not just to reduce the amount of data, it's also very helpful and necessary to set up such scenarios like we see here with this modular machine concept. So if you imagine a big machine has several parts, there might be a feeding unit, a packaging unit and so on. Each part of the machine, each unit is maybe provided and produced from different machine builders. So in the past, with these old concepts we see at the beginning, everything is connected and wired through the main cabinet and programmed in the main PLC. So the commissioning, setup, testing, everything could just be done when the complete machine is fully assembled at the end customer's plant. But today, with this modular automation concepts, we can set up each machine part independent from each other. So you can program the logic of each part in the part itself and just transmit some status and control information through the main PLC. So each machine builder can test his own part of machine before it is delivered to the end customer. And on site at the end customer, it just needs to be plugged together and tested in total. But you can save a lot of time and money at the commissioning at the end customer with this new modular concepts.
Yeah, and another benefit is, like we already mentioned, less data traffic due to pre-processed data results into unloaded networks, unloaded PLCs, and therefore also shorter latencies and, of course, lower data volume costs.
Yeah, and I think another big advantage is that we can decide where the data are transmitted to. So we later see this example here. Just another idea is if you have an encoder, in the past, just the position was the interesting value. So with that position, you can control the process. But when the encoder also transmits his own temperature, which is measured inside the sensor, you can get some information that you say when the temperature is increasing more than normally, there might be some mechanical problem. And in the past, you just recognize it when the machine is broken. But when you recognize it here, maybe early enough that you see temperature is increasing and increasing, you can get an alarm, send a technician to the machine before something is broken. So we have two different types of data. One thing is the position itself. This data is sent through the PLC to control the main process. But the temperature is maybe not necessary for the main process. That is just for condition monitoring or predictive maintenance scenarios necessary. This data is then transmitted from the field bus module directly to the edge controller, where it is pre-processed and sent into cloud environments or some higher level systems. So this data, which are not necessary for the main process itself, are also not necessary to be transmitted first in the PLC and then forwarded from the PLC into upper level systems. So that is much more flexible to configure the data flow where everything is going. And of course, also if you have the IT team taking care of this condition monitoring topics and so on, and you have the OT team taking care of the classic automation part of the machine, both can work independent from each other with the same hardware. You have the same encoder, but both of them getting their part of data. So they can handle that for their needs independent from each other. And for example, the IT team is not affecting the main PLC because the data is directly transmitted from the field without affecting the main PLC itself. So, Dustin, what do you think? Which applications could be solved already today?
Maintenance is a good example. Yeah. If you have many photoelectric sensors, let's say on conveyor belts, you may know that dust and photoelectric sensors are not the best buddies, so cleaning from time to time is necessary. But instead of waiting for a machine downtime just because of a dusty lens, these sensors already deliver additional data to indicate the signal strength beside the process data. And if this signal strength decreases, your maintenance staff can get an SMS or an email from the cloud with a notification to clean up the sensor. And thanks to the application-specific or location-specific tag built into these sensors, the maintenance staff knows exactly which sensor needs the cleaning. A similar example are IO-Link capable inductive sensors. Here the user can set two switching points, one for the application-specific switching point and another one for the indication of mechanical wear. And by getting an early warning here again, this can help you to reduce the risk of machine downtime. Beside that, the process data and the additional data that are already generated by the IO-Link capable sensors, this can give you a very easy retrofit condition monitoring. Many IO-Link sensors already have integrated temperature sensors, operating hour counters, humidity sensors, and other things. And if you already have IO-Link sensors in your plant, it is maybe worth to check out what benefits and additional data they can already deliver. And then just integrate the relevant data into a dashboard in your cloud, and you're good to go. So now you've heard something about some applications, but Christian, let's show some examples.
Yeah, I think now let's come here to practical examples. So what do we see here? We have here a dual sensor, which is measuring the position of a valve. And here we have the engine, which is moving. And if you trigger it, now the sensor normally just detects two positions. A valve is open and the valve is closed. These two bits are transmitted in classic applications to the main PLC to control the process. But yeah, what do we do here? We proceed to sense this data. So the open and closed signal is still transmitted to control the main process. But here we have this small field bus module, TBNS, one of the smallest I/O link masters on the market. We have here the integrated logic. From the dual sensor, we get just two bits, open and close. But the timer, which is programmed inside this standard field bus module, can measure the time between both positions. So when the closed position is left until we reach the open position, the time is measured and compared with some threshold limits. And yeah, as we see here, everything is green, so everything worked well. If Dustin now reduces the air pressure and triggers the valve again, we see the yellow tower light indicates a warning. So this value could be transmitted in the cloud system, for example, that we get a warning message. And this warning can be triggered for a service engineer to have a look on this machine. For example, if we have 10 machines in one plant, we can compare. If all machines are sending a warning, there might be an issue with the main air supply. If just one machine sends this warning message, we should have a deeper look into this part of machine. So yeah, here we could have a look right now what is going on there before the machine isn't working. So if we don't take a look and the air pressure is getting more down and down and we trigger it again, now we would reach a level where the machine could not operate 100% as it should. So with this information, we can react before we get a problem. And what is most important here in this example, this is not done in the main PLC. The logic is inside the field bus module, and this is a web-based programmed logic. So we offer you the possibility with our web-based engineering called RG to bring some logic in our standard multi-protocol I/O modules. And that is not just free of charge, that is also very easy to set up and use. And of course, the result of this logic can then be transmitted to the main PLC to get the warning, or if you don't need it for the main process, it can be directly forwarded to the edge controller. Yeah, so I think that is a good example to show here.
Yes.
But now let's maybe also have a look which product we also offer to set up such scenarios or even more. So we have a wide product range. Let's have a look.
Yes.
Okay. Yeah, so Dustin, let's have a look what else we can offer. So what we have seen here on the valve example was a small TBNS module. But depending what machine you are building, in which environment you are working, we have several products. So in the IP67, we have a huge product portfolio. So the smallest one, as we have seen, but also bigger versions and also modular I/O systems where you are very flexible how many and which type of variables or signals are connected. But also for the IP20 market, of course, we have modular systems as well as a very small IP20 block variant. So from the field bus modules, all modules support multi-protocol technology. So that means each module can communicate with Profinet, Ethernet IP, and Modbus TCP at the same time. So you can use it for machine builders with several end customers. You can set up the same machine and connect it to a customer using Profinet networks, or to deliver it at a customer and connect it to an Ethernet IP network. But as we have also talked about before, you can use two protocols in parallel to communicate one protocol through the main PLC and another protocol through the edge controller. So edge controller, we also have a nice product portfolio. So what we see here is several variants. We have here an IP20 variant, for example, with this antenna. So that can communicate with mobile networks if you don't have internet access or you have some mobile machines or applications. But we also have in IP67 variants in a block module or in modular systems, where you can directly communicate the IOs to the cloud. And also our HMIs. So this is a standard HMI, can be used as edge controller, but also our new IP67 HMI, what is a really nice product, can also be directly used as edge controller. So controller, how can we control something? We talked already before about RG, our web-based programming engineering. So RG is supported in the multi-protocol I/O modules, like the smaller one, the bigger one, and so on. But that is just logic inside one field bus module. If you have more to control, you can use one of our Codesys products. So with Codesys, we offer you a huge benefit. You have a full-blown PLC platform where you can communicate with several modules, not just Turck products. So you can also connect, for example, inverters and so on, and automate your complete machine. So we have Codesys products in IP67, what is quite unique on the market. But of course, we have also Codesys inside our HMIs, and we can also program some couple modules for the modular system in IP67 and in IP20. So it is really depending on your application. Mostly we can find product which fits best to your needs. So from the edge controller, the data is then transmitted to the cloud. So of course, you can communicate to each cloud you want. You are very flexible with our product, so it is an open platform. You can use MQTT or OPC UA to communicate to more or less every cloud system. But of course, a big benefit is that we as Turck offer also our own cloud solution. So why do we do that? We offer a flexible product which is perfectly integrated also into our hardware products, that hardware and software perfectly fits together, and it is quite easy to set up your cloud scenario. You can not just transmit data. You can, for example, also do some firmware update of the device, control VPN connection, and so on. So hard and firmware perfectly fits together. And what's important to know about our Turck Cloud, we have several hosting options, which makes it very flexible and depending on your customer needs. We have, for example, hosting options where we as Turck host the cloud as service for you. So you just register, you connect your devices, and you can work with it. You can compare it, for example, when you register for your private use an email address. You get your email address, you register, you can use it, and you do not need to take care about backups, updates on the email server itself. But if you use an email server for your work communication, you might want to have some email address with your company name in the address instead of some other provider. So therefore, we offer the same solution here with our cloud, that you can brand label the cloud itself, that it is from the look and feel like it is done from the machine builder. So that is perfectly for OEM customers who want to sell their machine directly with an integrated cloud solution. So they can offer their end customers a machine including cloud solution, and everything has a look and feel from the machine builder. But another hosting option is the on-premise topic. So that is a real benefit and a real possibility to do something different than other cloud solutions offer, because we can also sell you the software itself, that you can install it on your own server. So of course you can trust us, but if you say, okay, I don't trust the internet itself, I don't want to send data to some servers, you can install the cloud on your own server or a data center where you rent some servers and set up your cloud system there. So you get the functionality from us, but then you are responsible for hosting updates and so on. But all the data is controlled by you, and you have 100% your hands on it, where the data is transmitted, where the data is stored, and everything like that. Yeah, so Dustin, I think that was a short overview from the field bus level through the edge devices up to the cloud level. Can you show us maybe an example how we can do condition monitoring scenarios in combination with our cloud?
Of course. What you can see here is our Turck dashboard, to a cloud dashboard. And there are some diagrams about the sensors that are built here on this panel. So what you have here are some vibration sensors, there are some flow sensors, cabinet condition monitoring, also a very good topic. We also have a presentation about that. And also some valves from other companies, because IO-Link is an open standard and we don't want to show just Turck products here. And we want to show that other products can be integrated in the Turck cloud as well. And this is a good example here, the vibration sensor. I can hit it maybe 3 times, and then you will be able to see a vibration peak right now. And this is something that you can do a retrofit condition monitoring on your motor or drive or something like that. And then you can act before the machine is broken. So if anything vibrates in your motor, you know there is some wear maybe, and then you can do some predictive maintenance. So what is the conclusion? With our portfolio, we can help you to build your own future-proof IIoT infrastructure.
Yeah, and hard and software out of one hand easily enables you to offer new concepts and business models to your customers.
And if you have any further questions, please leave them down below in the chat.
Thanks for joining.
Thank you.